Okay, Noelle, this one's for you. I redid your calculations to check everything for problem number 4 that you were asking for my help on, and I redid my own calculations to double check everything. So, long story short, we have two charges, and they're some distance apart, 0.85 centimeters, and one is positive and one is negative initially, and then they touch. And in part A, after the two balls have touched together, what is the charge on each ball? The key concept here is assume that Q1 final, the charge of 1 final and the charge of 2 final, because the charges will equally be distributed when touched. So when they're touched, they equal each other. So that's why you were able to do this. So you were able to calculate F2, or 1.3 newtons, equals K times Q1 final times Q2 final over R squared. Well, we know that these are final after touching, and they're the same, so you can just convert it to the Q final squared. And then, as you did in your homework, you were able to just solve by algebra, redistributing the terms until finally you get Q final for both charges, because they're equal, equals this, which you got equals to roughly 1.02 times 10 to the negative fifth coulombs. Okay, so that's your final charge. Well, using that numbers, the next question, part B, says, because they were touched together, one ball had a positive charge, how much charge did that ball have? Well, really what this question is asking, and here's the part I know you don't like, but it's algebra, it's math, and it's getting into how do we find how much charge was transferred. And again, knowing that the charges are equal after they transferred, that implies that the amount of charge transferred from Q2 that was positive to Q1 that was initially negative is the same amount of charge that was transferred, because matter can't be created or destroyed theoretically, right? So therefore we know that Q1 initially was negative, it gained charge, and Q2 initial lost charge. So how much? That's what we're actually solving for here, and that will give you the answer for both part B and C. So we need to find out how much. And therefore we can rewrite these equations that I wrote atop, because Q1 final equals Q2 final, then Q2 initial minus some value, right? Because it was initially positive, Q2 became Q2 final. And likewise, therefore, minus Q1 initial plus some positive charge became Q1 final. So we can rewrite that usefully, and here's the relationship right here, like I was telling you earlier, the process, which I didn't draw you a picture on top. The process, though, is picturing it, writing the equations, and then building the relationship, right? So here's where I'm creating the relationship with math based on their initial and their final charges. So rewriting what I talked about up here in terms of their initial charge, I can say negative Q1 equals Q1 final minus X. We don't know how much, but that's what, in terms of Q1 final, because we know that already, that's how it changed from Q1 initial to Q1 final. Likewise, Q2 initial is equal to Q2 final plus X, because it was more positive and it lost its positive charges by some X over here to Q1 negative, making it become positive. So we can say that initially the force between the two balls was 2.3 newtons and the distance was the same, 0.85 meters. So we need to solve for the charge transferred, or I'm just going to call it X, because it is the same for both. So we substitute. So setting up our equation again, but this time using force 1, or 2.3 newtons, same K, we say Q1 initial times Q2 initial, absolute value, over R squared. Well, now start substituting, right? So we can substitute for Q2 initial based on this equation, or Q1 initial, excuse me, right there, Q1 initial. This becomes this, because of the equations that we wrote up here, right? So we substitute all of this into here. Likewise, we substitute all of this into here, and then we just expand it. Now it's just the algebra. the algebra is just expanding this right here. Well, because we have a minus, positive, those when expanded become minus qx times q final, and this becomes positive times qf final. So negative qf final plus minus qf final equals 0. I used qf final here, sorry, I should have mentioned it, because remember we know that the final value of both of them is the same. So I just substituted q1 final, q2 final, just q final, because as we solve for up here in A, they're the same. So we have the negative sign out here because q1 is initially negative, and then we just, again, like I said, we get rid of these two charges. We get some minus x squared, which we're going to solve for, but we don't have to use quadratic because these middle two terms go away. So now further reducing it, you have q final squared minus x squared. Further reducing it, moving the k and r squared onto this side with f. Now you just have f times r squared over k equals negative q final squared plus x squared, because I distributed the negative across. Well, it's just algebra now. So just redistributing terms, finally x, or the change in charge between the two, becomes the square root of f1 times r squared over x plus qf squared. Okay, so we can't move these terms, this term over here, until after we move the k and r squared term onto that side. So finally, when we solve for x, we get roughly 1.69 times 10 to the negative coulombs transferred positive charge. That means that the initial charge is of Q2 was x, because this is what we took from it. So we know it's Q final plus this equals, so that's the initial charge of the positive charge, because we just add this back on to positive charge since we know we took it from it when they touched. Likewise, we know this is how much was added on to the first charge. We take it back away from it, and it becomes the negative 6.7910 times 10 to the 5th coulombs, and that's within 0.01 accuracy of what your quiz accepted. So, like I said, it's a little hard on the time constraint I wanted to be able to check all these numbers. Now I've checked them. I feel fairly confident, a little concerned on some of these signs, but I wanted to get this to you sooner than later.